In this video, we're going to take a look at each example for factoring expressions and then solving. So I have 4 different examples here, and this is basically what we're going off of. We have to see how many terms are there. Based on that, you want to first take out your GCF before you figure out what factoring method to use. So after you take out your GCF, you're going to see how many terms you have. And then based on how many terms, these are your options. So if you have 2 terms, it could be difference of squares, difference of cubes, or sum of cubes. Remember, for all of these, for the factoring, we don't even use this part of the formula. This first part of the formula tells us if we could use it, right? If we have a perfect cube minus a perfect cube, then we can use this formula. And this is the part of the formula we use to factor. If we have 3 terms of trinomial, that's where we do the a times c, and what will add up to be the b term. If there are 4 terms, then we just do the grouping or box method right away. So looking at this first problem, we have to have it set equal to 0 before we can factor, so that's already done here. And I want to see how many terms I have. 2 terms, so 2 terms. So is 8 or 125 a perfect square? No. Are they perfect cubes? Yes, 8 and 125 are both perfect cubes. There's a plus sign here, so I know I would be using the addition, the sum of cubes. So I'm just going to put this behind my paper here. We have to figure out what our A and B is going to be for this problem. There is no GCF for this, 8 and 125. So we're going to figure out A and B. So A and B. 8 is a perfect cube, and we can figure out its cubed root using the calculator. So you can make a list of your numbers to the 3rd power, or we could just hit the math key and go down to the cubed root and type in 8. That will be 2. So this is my A term, so I have 2. The cubed root of x cubed. So let me just write this out. Cubed root of x cubed, that's like when we have the square root of x squared, how it cancels out the exponent. So I would just be left with x. 125, again, I can use the math key down to number 4, root 3, or cubed root, and the cubed root of 125 is 5. And that's my b term. So I'm just going to plug my a and b into just this part of the formula. So this will be 2x plus 5, and then 2x squared. So notice I'm using parentheses, minus 2x times 5 plus 5 squared. Okay, next step I'm going to evaluate. So I'm actually going to square this and multiply here. So this 2x plus 5 stays the same. 2x squared. So the parentheses are important, so I know the exponent goes to the 2 and the x. So 2 squared is 4x squared, minus 2 times 5 is 10x, and then 5 squared is 25. Okay, so this is it completely factored. I'm all done factoring at this point. I do have a trinomial, but after we use this formula, this will not factor any further. So the next step is to solve. So 2x plus 5, I'll set that equal to 0 to solve. So solving here, I would subtract 5 and divide by 2. So x is equal to negative 5 over 2. So that's one of my solutions. For the next one, 4x squared minus 10x plus 25. So I'm going to use the quadratic formula. So quadratic formula can only be used when our highest exponent is x squared. If this was x to the fourth, then it's no longer a quadratic expression. So x squared is what makes this a quadratic and why we can use the quadratic formula. So let's write the quadratic formula up here. Right, so using the quadratic formula, a is equal to 4, b is equal to negative 10, and c is equal to 25. So this a and b from before was to factor this expression to get this. Now we have a new set of a, b, and c from this trinomial. I'm going to plug the a, b, and c into my quadratic formula. So this is x equals negative b plus or minus square root of b squared minus 4 times a times c all over 2a. Okay, so negative 10 is a positive 10. This, I'm just going to type it in the calculator just as I see it. So parentheses, negative, so there's not as much of a glare, so negative 10 squared minus 4 times 4 times 25. Oh, shoot. Negative 10 squared minus 4 times 4 times 25. So that would be a negative 300. And 2 times 4 is 8. I have to simplify my square root. So just off to the side here, the biggest perfect square that can go into 300 is 100. So we also have a negative. So there's my negative 100 times 3. So negative 1 times 100 is a negative 100, times 3 is negative 300. Root 100 is 10. Root negative 1 becomes our I, root 3. So this simplified be 10 plus or minus 10I root 3 over 8. So after you simplify your root, this is where you can reduce your fraction. Okay, so we cannot reduce the fraction until our root is simplified. So at this point, I look at the numbers on the outside. It doesn't matter what's in the radical here. We can't divide anything out of that. But these three numbers, 10, 10, and 8, I could divide 2 from each. So this will reduce to 5 plus or minus 5I root 3 over 4. And there's my answer. For the solving, you look at your original problem. The highest exponent is how many answers you should have. I should have 3, here's 1, and then this counts as 2 because we have plus or minus. So this could be either 5 plus 5I root 3 over 4 and 5 minus 5I root 3 over 4. Okay, so that's factoring and solving with our perfect cubes. Next, I have this problem. I need it equal to 0 before I can do anything. So I'll subtract 72. Write this in standard form. So highest exponent first. 6x squared would be next. So you want your exponents in descending order. So 4, 2, and then no exponent for variable. Okay, now I have 3 terms. So looking back, this is 3 terms, a trinomial. So this means I have to do the a times c and what will add up to be b. A times c here is negative 72 x to the fourth. And then our b term is 6x squared. Thinking of factors that of 72, negative 72, that will add up to be 6. So 72 divided by 2, 36 and 2. So I'm just brainstorming my factors of 72. So about 72 and 3 and 24. 72 and 4 is 18. 72 divided by 5, that doesn't work. About 6, 6 and 12. Actually, I'm going to stop here because if I make one of these negative, right, negative 18 and 4, or 4 and negative 18, that would give me a positive 14 when I add. But 6 and 12, if I make 6 negative, 12 positive, that will add up to be 6. So this will be negative 6 and positive 12. So that multiplies to be negative 72 and will add to be positive 6. Now, since my exponents are, or my variables have exponents of 4 and 2, this bottom one is not usually, it's always the indicator of what the variable and exponent should be for these two. So if this is x squared, then both of these should be x squared. Okay, so from here, you're to use whichever method you usually use for factoring. I'm going to set up the box method. The first term goes in the top left. Last term goes in the bottom right. So after you do this part, don't forget about our original. People tend to use just all of these numbers in the table, but we want to use the original factors, and just the 6x squared we're replacing with these two numbers. So I'll have negative 6x squared and 12x squared. Okay, so figuring out our GCFs here, again, you can use the calculator for finding your GCFs. Between 12 and 72, you go to math, over to number, down to GCD. 12, comma, 72 will be 12. So my GCF here is 12. Between these two, I see both have an x in the box, so I'm going to take an x out, and I choose the smaller exponent, which is 2. Between these two, they both have an x, choosing the smaller exponent of 2. And lastly, both of these have a negative. And I know from before 6 can go into 72, so my GCF will be 6. Or I could use the calculator again. So this is going to factor out to be x squared plus 12 and x squared minus 6. Okay, now we just need to solve. I'm finished factoring. I have two binomials. Neither of these are difference of squares or difference or sum of cubes, right? 12 is not a perfect square or a perfect cube. Same with 6. So I'll do x squared plus 12 equals 0. So setting each one equal to 0. Okay, solving with square roots now. I'll subtract 12 to the other side and then take the square root. Okay, so this will become, the square root cancels the square. This just becomes x. Biggest perfect square that can go into 12 is 4, right? So this can be 4 times 3. Square root of 4 is 2. So don't forget, solving with square roots, we have plus and minus. Square root of 4 is 2. Negative becomes I root 3. So there's 2 answers there. So it could be positive 2i or negative 2i, 2 answers. Here, I'll add 6 to the other side and then take the square root. So this becomes x equals plus or minus root 6. Again, looking at the original, it's x to the 4th. That's how many answers I should have. I have 1, 2, 3, 4 answers.